Now let's talk about the properties of ionic compounds and how they relate to the structure of the compounds. So first off, ionic compounds are solids at room temperature with high melting and boiling points. What does high mean? Usually 1,000 degrees Celsius or higher, so yes, quite high. And our picture of a solid ionic compound can be exemplified by looking at a sketch of sodium chloride. And for sodium chloride, we'll have the smaller positive ions being the Na pluses and the larger chloride ions being the Cl minuses. And there is, from the pictures on the previous page, and here we're sketching it in 2 dimensions, positive, negative, positive, negative, positive, negative. And all the tiny ones are positives, and all the larger ones are negatives. And this is a picture of solid sodium chloride, and there are strong attractions between the positive and the negative ions. And these strong attractions make the ions hard to pull apart. And what we've said before, though, is that temperature adds kinetic energy, adds kinetic energy, adds kinetic energy. So here's my sodium and my chloride ions. And they're very strongly held together. So they're vibrating, they're vibrating, they're vibrating. Temperature is going up. They vibrate more until they're vibrating so much, they have so much kinetic energy. And then eventually, at temperatures above 1,000 and sometimes 2,000 degrees Celsius, you've added enough kinetic energy to make them into a liquid. And in the liquid phase, they're vibrating and moving. So, yes, eventually they do become liquids and gases, but in our picture of this process, you add a lot of heat, raise the temperature a lot, add a lot of kinetic energy, and eventually you will get liquid NaCl, in which the ions and these are the tiny ones, or the pluses still, in which the ions are moving around, and you do have ion motion. Here you have no ion motion, or let's say this, I should say only ion vibration in place. So that is a type of motion, but here there's ion motion moving past other ions. Here they're vibrating, they have motion, but they're staying put in the same lattice or position. All right, so but there are strong attractions. Eventually you add enough heat and enough, raise the temperature enough, and it will become liquid, and you do that again and it will become a gas. They are cleavable, and if you've ever seen a salt crystal in your salt shaker, you take it out, they've got little facets or little shapes to them. They look like little tiny cubes, or they have cubic faces, like so. So that might be a grain of salt, which is made up of billions upon billions of sodium chloride ions. And if you've ever worked with magnets, and you take 2 magnets and you try and bring them together, you can see if you try and bring them together so that they repel each other, it's very hard to do, but then you shift them like one tiny bit and they're attractive. Well, sort of that's the opposite sort of happens with these. If you try and cut them, you can very easily take the pluses and minuses and line up the minus and minus and then cut them very easily because minus and minus leads to repulsion. So they're cleavable, which means they're cuttable. And you're left with crystal cubes or squared off faces too. That is another aspect of ionic compounds. Solids are poor conductors of electricity. Liquids are better conductors of electricity, as I showed you in the previous picture. So the solids. So each ion only vibrates in place. No. Well, let's just stop while we're ahead. Liquids, on the other hand, the ions do move in the liquid phase. So that's why solids are poor conductors of electricity, and these are, again, we're only talking about ionic compounds here. That's the section. Liquids are better conductors of electricity, but still not very good.